All right, viewers, this is a continuation of our discussion on the second series. Sorry about that. My internet got disrupted. The second series was not completed, so I'll complete the rest of the question here in this video. All right, so let's get started with this one. So like I explained earlier, I said the first you want to do, you distribute 2, so you have 5 into 2x minus 2 times, put them in brackets, times 5 into x plus 1 is equal to, this whole guy in fraction will be 4/100. We've talked about this guy earlier, so we know what it means to transform decimals to fractions. Now, the next thing we want to talk about is, you see they have the same base and they are multiplying. You have to take one of the base and add their powers, right? From these laws of indices, an times an, you take one of the base and you add up their exponent. So you have now 5, you add up 2x minus 2 plus x plus 1 equal to, this guy, 4 here is 1, 4 here is 25. So that would give me 1/25. So let's add up. So we have 5, we have 2x minus 2 plus x plus 1 equal to, all these guys is the same as writing 1/5 to the power 2, because 5 to the power 2 is 25, right? So let's proceed. Now I'm going to add 2 to the x, 2x plus x. So adding 2x plus s will give me 3x, and minus 2 plus 1 will give me minus 1, then equal to, all these guys is the same thing as 5 to the negative 2. Remember, when you have 5 to the negative 2, you write these guys as 1/5 to the positive 2 by removing this negative power from here. We've talked about this earlier. So now the whole idea of doing this is to make them have the same base, so we can cancel them out and equate the exponent. So we have 3x minus 1 is equal to minus 2. So we have 3x is equal to minus 2 plus 1. When you take minus 1 to this side, so you have 3x is equal to minus 1. And of course, s will be minus 1/3. Divide both sides by 3. So that's our answer, is minus 1/3. So I hope this is clear. So let us go to the next question. This is question 8. All right, so let's go to the question 9. All right, question 9 is very, very interesting, just like this one. It says 9 to the power 2x minus 1 times 3 to the power 3x minus 1 is equal to 27 to the x plus 3. How can we find the value of x in this initial equation? Now, when I see all these base, I know they should all have a common base, which is 3. 27 is the same as 3 to the 3. 9 is the same as 3 to the 2. So go ahead and substitute those guys for them. So you have now 9 will be 3 to the 2, or to the 2x minus 1. Then times 3 to the 3x minus 1. And 27 should be 3 to the 3, then all to the x plus 3, right? Now go ahead and distribute all these guys. So you have 3. You have 4x minus 2, that is 2 times 2s, 2 times minus 1. Then times 3, you have 3x minus 1. I like to put them in bracket because the next step is going to help me out. So here will be 3 into 3x plus 9, right? So the next thing you want to think about, they have the same base and they are multiplying. So you want to take one of the base and add their exponent. So you have 4x minus 2 plus 3x minus 1 equal to 3 into 3x plus 9. Now you can add these guys and these guys, they are like terms. So you have 4x plus 3x will give me 7x, minus 2 minus 1 should give me minus 3. That's equal to 3 into 3 to the power 3x plus 9. Now, the whole idea of doing this is to make their base the same so that we can cancel out the base and equate the exponent. So we have 7x minus 3 is equal to 3x plus 9. So now you collect like terms, so you have 7x. These guys, when it comes to this side, becomes negative 3x equal to 9. When negative 3 comes to this side, becomes positive 3. So 7x minus 3x will give me 4x, and this guy should give me 12. Divide both sides by 4, so x must be equal to 3. So this is question 9 or question 10. I can't remember the question number, but that is pretty much how you can solve that problem. So let's go to the next example. The next example here is question 11. It says 0.25 all to the power x minus 1 is equal to 32. Now, how do you simplify this one? Very simple. Now, the first thing you want to do is to go ahead and resolve these decimals to fraction. So 25 in fraction will be 25 over 100 all to the power x minus 1 is equal to 32. Now, still go further to dissolve these guys. You know, 25 here is 1, 25 here is 4. So I have 1 over 4 all to the power x minus 1 is equal to 32. Now, from here, because I have 32 here, you know, 32 can be written in the base of 2 as 2 to the power 5. And 4 can be written in the base of 2 as 2 to the power 2. So I want them all to have the base 2. So remember, this 4 is the same as 2 to the 2, then all to the x minus 1 is equal to 2 to the 5. Then I can go ahead and say 1 over 2 to the 2 is the same thing as 2 to the negative 2 is equal to, 2 to the negative 2 is just this guy right here. Then all to the x minus 1 is equal to 2 to the 5. I believe you all understood how I transform this guy to this guy here, because you know, when you have 1 over 2 to the 2, this is the same thing as 2 to the negative 2. You know, when you want to remove the negative index from here, you take a fraction of 1 over that guy without the negative index. So distribute with negative 2 into these guys like this. So you have 2 into negative 2x plus 2 is equal to 2 to the 5. And the base we cancel out. Minus 2x plus 2 is equal to 5. Collect like terms. So you have negative 2x is equal to 5 minus 2. And that should give me 3, right? Now you divide both sides by negative 2, negative 2. So now you have x is equal to 3 over negative 2. And finally, you have this negative guy will definitely come to the numerator. So you have negative 3 over 2. So your final answer is negative 3 over 2. All right, let's go to the next question. That will be question 12. All right, if you're enjoying this video, I want you to give me a thumb up and share this video to other learners within your space, okay? I will really appreciate that if you share this video to other learners within your social medias. Thank you very much for that. So let's take question 12. It says 4 to the x is equal to 2 to the 1 over 2 times 8. Now, whenever I see this kind of initial equation, the first thing I want to do is to make them have the same base. You see, 4 and 8 can be written in the base of 2. 8 is the same as 2 to the 3, and 4 is the same as 2 to the 2. So go ahead and simplify this guy. So 4 will be 2 to the 2 all to the x, then 2 to the half times 2 to the 3. That is, with this, you can easily simplify this. So now you multiply. So you have 2 to the 2x is equal to 2 to the... Now you see they have the same base and they are multiplying. Take one of the base and add their power. So you have 1 over 2 plus 3, right? That's easy, right? So the next thing you do, you add up this exponent. So you have 2 to the 2x is equal to 2 to the... Now, if you add 1 over 2 plus 3, because I want them to have the same denominator, I can put 2 over 2 here. So that should give me 1 over 2 plus 6 over 2, which is 7 over 2. Or how to add these fractions, you multiply these guys and these guys. So 1 times 1 is 1 plus 2 times 3 is 6 over 2 times 1 is 2. So that will give me 7 over 2. So here should be 7 over 2. The base will cancel out, so you equate the exponent. 2x is equal to 7 over 2. Now, you can go ahead and divide both sides by 2. You divide here by 2. In this case, you divide here by 2 like this. It's the same thing. 2 cancel out to x is equal to 7 over 2 divided by 2. This is 2 over 1. So you change it to times, you have 1 over 2. And finally, x is equal to 7 over 4. This is how it is. So, divide by 2, when you change division to multiplication, this guy is going up, this one is coming down, then you can now go ahead and simplify. So this is question number 12. All right, it has been a long question. I believe most of the questions still remaining here will not be a problem for you. But let's take this last one in this set of questions. Question 13. It says 1 over 9 to the x is equal to 3 to the negative x over 3 times 81. How do we simplify this problem? Now, when I look at all of this problem, I see they all have a common base, which is 3. 9 can be written in the base of 3, and 81 can be written in the base of 3. So now I go ahead and simplify that. I have 1 over 9 is the same as 3 to the power 2x. So this whole guy is 3 to the negative x over 3 times 3 to the 4 power, because that is 81. 3 to the power 4 is 81. So I have now 1 over 3 to the 2x is equal to 3 to the negative x over, you see this guy is having a power 1. So when you apply the law of indices, you take one of the power and you add their exponent, so you have 5, right? Then you can go ahead and simplify. You can go ahead and maybe cross multiply if you want to. But for this case, I would like to cross multiply. So if I cross multiply here, I have 3 to the power 5 is equal to 3 to the power 2x times 3 to the power minus x. Now, take these guys to this side. You see now you have 3 to the power 5 is equal to, they both have the same base and they are multiplying. So take one of the base and add their exponent, 2x plus minus x. So that will become 3 to the power 5 will now be equal to 3 to the power 2x minus x, because plus minus turns out to be negative sign. So you have 3 to the power 5 is equal to 3 to the power 2x minus x. This is like 1x. Will give me just 1x, which is same as x. So the base cancels out and 5 must be equal to x. Or you say x is equal to 5. So viewers, this is our 5th question on this series. So let's move to the last stage of our question series. So that will be question 14. I have this expression as it says 9x squared is equal to 72. What is the value of x? Now, to solve this problem, you just need to apply the laws of indices. That is pretty much what you need to do. So, from here, you can divide both sides by 9 because you're looking for the value of x. When you divide everybody by 9, so you have 70, you have this 9 we cancel out. So you have x squared is equal to 72 divided by 9 is 8. So here you have 8, right? So from here, you can actually take the square root of both sides so that this guy will cancel out the root. So x is equal to the square root of 8. And that is the same as x is equal to 2 root 2. So this is your answer, and this also is your answer, right? How did I get this expression? Root 8 is the same as 4 times 2, right? So that is the same as square root of 4 times square root of 2. Square root of 4 is 2, so I have 2 times square root of 2, and 2 times square root of 2 will give me 2 root 2. That's how I got this answer. So let us go to the next question. That will be question number 15. Question 15. What is question 15? It says the cube root of 4 to the power 1.5. Wow, this is quite interesting. This is 1.5, okay? Now, first thing you want to do here is to transform this decimal to fraction. So you have the cube root of 4 to the 15 over 10. And 15 over 10 is the same thing as 3 over 2, because when you divide 15 by 5 and divide 10 by 5, that should give me 3 over 2, right? Yes. And from here, you can go ahead now and transform this cube root as 4 to the 3 over 2, then all to the 1 over 3. Now, this cube root is actually 1 over 3 in index form. So you can see that this 3 can cancel out this 3. So finally, you're left with 4 to the 1 over 2, and that is the same as square root of 4, and that should give us 2 as the final answer. So let's go to the next question. Question 16. It says 35 x squared y squared over 5 x cubed y cubed. How do we simplify this? The way I like to do this, I like to split them up. So I have 35 over 5 times x squared over x cubed times y squared over y cubed. They are all the same thing. When you multiply all these guys, you see have all of them like this. Now, 5 can divide 35. That will give me 7. Then apply the law of indices here. Take one of the base and subtract. You know, when you have a to the m over a to the n, this will become a to the m minus n. So this is going to be like 2 minus 3. Then for this one, you have 2 minus 3, the same. So that will give me x to the negative 1 times y to the negative 1. So when you multiply out, this whole guy becomes 7 times. This negative 1 can also be written as 1 over x times 1 over y, right? So from here, you can, this is over 1. So finally, our answer is 7 over xy. When you multiply through, you get this result. So let's take another example. That will be question 17. Says 3q minus 1 times 3, 1 minus q. Now, what you should observe here is that they have the same base and they are multiplying. So take one of the base and add their exponent. So I like to put them in bracket because I want to add them. So I have q minus 1, then plus 1 minus q. So remove the bracket now. So you have 3q minus 1 plus 1 minus q. Now collect like terms. You see this q here. You have q here. Bring down this q. You have minus q. Then you have minus 1 plus 1 like this. Q minus q is 0. Minus 1 plus 1 is 0. So you're ending up 0 in your power. And 3 to the power 0 is just 1. So this is very interesting question. So we'll take the last question for today and we'll call it a day. That will be question 18. It says 2 root x is equal to 4. How do you find the value of x? Of course, divide everybody by 2 like this. So you have square root of x is equal to 2. Now to remove this square root, take the square of both sides. Take the square of both sides. This square will cancel out the root. So x is equal to 2 squared, which is 4. Now, I feel like solving the last example, that's question 19. That is question 19 is saying a to the x minus 1 is equal to a to the 2. They both have the same base. So just go ahead and cancel out the base, equate the exponents. So take like terms. So you have x is equal to 2 plus 1. And of course, x must be equal to 3. So viewers, there are a couple of questions here I want you to go and try out by yourself. These are your assignments. So let me give you some assignments. You should go and do assignments. So question 1 is 2 to the x plus 1 is equal to 1. And number 2, you have 27 is equal to 3 to the 2x minus 1. And question 3, you have square root of 0.0081 all to the 3 over 2. So these are what I want you to go and try out yourself. And if you still have any question regarding indices, please let me know. I'll do well to simplify those questions and send back to you. Thank you very much for watching. I hope this has been a very good time for you. If you love what to do, share this video to other learners. I want to see you in the next video. Have a wonderful day. God bless you and bye-bye.